Regarding the muscle is a facilitate motion and storage of glycogen and protect organs. The motor unit is motor neuron and a muscle fiber it innervates. Smaller the unit, precise the control, larger the unit, the better, the stronger the control. Sacroilioma is a muscle cell membrane. Microscopically, each muscle bundle is covered by epimysium and contain fascicles, which is covered by perimysium. And perimysium contains muscle fibers called myofibrils, which is covered by endomysium. Myofibril consists of sarcomeres, which in turn has thick filaments and thin filaments. Actin is a thin filament, has troponin, to which calcium binds, and tropomyosin, which covers the binding sites for the myosin actin. It also has satellite cells. It stays dormant until muscle injury occurs, responsible for producing new muscle and new satellite cells in response to injury. So sarcomere, which is present in the myofibrils, is the basic contractile unit. It is 2.5 micrometer and consists of, then you draw Z to Z line and then describe. Z line is between sarcomeres. M line goes through the center of the sarcomere, connecting myosin. A zone is called anisotropic band, is thick myosin filament anchored to M line. H zone is myosin filament only. I is the gap between A band and it has only actin filaments. And Z protein is between sarcomeres. These shortening and contraction occur by the movement of actin filaments over myosin filaments. When asked about the contraction, draw a neuromuscular junction and talk. The basic concept is a contraction-excitation coupling. When the action potential goes through the nerve, it arrives, then the action potential arrives at motor neuron end plate, which causes calcium into the nerve, which releases acetylcholine into the synapse. Acetylcholine then activate acetylcholine receptors. When acetylcholine receptors enters, they open sodium channels on the postsynaptic muscle membrane and let the sodium go into the muscle membrane. The muscle fiber has resting potential of minus 95 millivolts. When the influx of sodium happens, it reduces charge. When end plate potential reaches minus 50 millivolt, action potential is created. This causes release of calcium from sarcoplasmic reticulum through the T tubules into the muscle cytoplasm. Now calcium acts at troponin on the actin and causes tropomyosin to move and exposes the myosin binding side of the myosin head attached to the actin and causes sliding motion. Usually ATP is dependent. Action potential sweep down all the length of fibers as it does in an axon. This whole contraction is called excitation-contraction coupling. Later on, enzyme acetylcholinesterase break down the acetylcholine in the postsynaptic cleft, resulting restoration of outflow of potassium ions. Botox cortoxin is known for blocking the release of acetylcholine from the end plate, while myasthenia gravis is due to the antibodies that block acetylcholine receptor at motor end plates. Regarding type of muscles, they can be type 1 plus or type 2 muscles. Type 1 is slow red ox. What does it mean? It's slow twitch, it's aerobic, needs oxygen, high number of mitochondria, low strength, fatigue resistant, endurance activities, balance, and posture. Require oxygen and have more vascularity and myoglobin. So these are mostly commonly in the marathon runners. Type 1 is present. Type 2 is fast switch, is anaerobic, glycolytic. Type 2A is oxidative and glycolytic, and type 2B is glycolytic. It's high strength, less mitochondria, they are fatigable and intermediate fatigable. These are in fast runners or sprinters. Then you can classify as per the type of muscle. Macroscopically, you can classify into a parallel muscle, that is sartorius, fusiform like bicep, fan shape like pec major, unipennate like palmar interossei, bipennate like rectus femoris, and multipennate like deltoid, or circular like orbicularis oculi, or triangular. Regarding the type of muscle contraction, force of muscle is proportional to the cross-section and fiber strength. Overloading leads to muscle fiber hypertrophy. Speed, amplitude of contraction is related to the length. Working capacity is force into amplitude. There are three most common types: isometric, isokinetic, and isotonic. Isometric, length is constant, like pushing immobile object. No joint movement is there. Isotonic, force is constant. Length changes, like bicep curls. When muscle shortens, this is concentric. Muscle lengthen, eccentric. Isokinetic, when muscle contraction with constant speed. This is best method to maximize strength. Type of muscle exercises: closed chain, when the distal extremity is on the ground, like squats, pull-up. Open chain, when the distal is not on the ground. This increases joint reaction force. Or passive stretch, like hamstring while touching toes. When a muscle injury happens, there is soreness. This is because of edema, inflammation, and raised creatine kinase. Strain at the myotendinous junction, inflammation followed by fibrosis. Atrophy is from disuse or nerve injury. Fatty infiltration is seen.